This is a tiny robot that can solve any maze without making a single wrong turn. And I built it because I'm facing off against some of the world's fastest maze solvers. But what's really interesting is that by testing tons of different methods, mazes, and materials, I figured out an extremely unorthodox method that has never been used before, but that is faster than all humans and all other maze solving robots. And using this method, I'm going to build 3 robots that can hopefully beat all humans and solve much more complicated 3D mazes using robots with the ability to climb vertically, navigate uneven spaces, and travel quickly, all without ever making a single wrong turn. Or at least that's the goal. Mazes have always fascinated me. As a kid, I loved drawing mazes for other people to solve. I even created 3D mazes I couldn't physically build. Over time, I've drifted away from this passion. So in this video, I'm building 3 unique mazes and 3 robots to solve them, reviving and leveling up my childhood maze making skills. Here's how we'll decide if I'm successful. If my robot solves a maze faster than the average human, they get a point. But if humans solve it faster, then they get a point. It's a best out of 3 maze solving showdown between my robots and humanity. First, I needed to build the mazes. For the first one, I'm starting with a classic grid maze, the kind you see everywhere. And it turns out thousands of engineers worldwide compete to build the fastest maze solving robots for these exact types of mazes. So I used a piece of glass as the base, and then I laid down several layers of this tacky tape stuff for the walls.
Look at how messy the apartment is. All of the strips that come off of these.
And then I used another piece of glass to put on top. This maze wasn't too complicated to build, but it took a lot of work because of how big it is. But now that I had finished it, it was time to try and build a robot that could solve the maze faster than an average human. I didn't realize until making this video, but maze solving robots have been around for a long time, and their navigation methods have evolved dramatically. Some use magnets, ultrasonic sounds, or infrared sensors to find the best path. But remember how I said my robot would use a method that's never been done before? That method is, wait for it, air pressure. To my knowledge, this method has never been used with maze solving robots. Probably because it's definitely against competition rules, but I'm not trying to follow any rules. I'm just trying to make the fastest maze solving robot no matter what it takes. Here's how it works. If I place an object in the maze, and then somehow lower the air pressure, the higher air pressure outside pushes the object forward to try to fill in the more empty space. But what happens when the object reaches a fork in the road? Well, as long as the correct path always has less air pressure than the other path, it will always choose the path with the lower air pressure, and the same force will drive it forward. So the secret to my robot is that it doesn't even really need to be a robot. It just needs to be an object that is easily affected by the air pressure. So the real question was, how was I going to change the air pressure in the maze? And to do that, all I needed was a basic household vacuum. If I attach the vacuum to the end of the maze, the object should in theory make it to the finish every time. The problem here is that the bead that I used is pretty small, so instead of the air pressure changing in the maze, it just created a wind tunnel effect. And the problem with this is that the bead is so light that it would sometimes blow the bead right out of the right path. I spent days trying to find or create an object that wouldn't do this, but it was a lot harder than I thought, because I needed an object that would fit perfectly between the walls. But since my maze wasn't precise enough, the space between the walls wasn't consistent. I tried various shapes that could squash and bend to fit the walls, but nothing worked. It was frustrating because the concept seemed so simple. At one point, I completely switched methods and tried using gravity to solve the maze, adding enough beads to eventually fill every wrong path, but that clearly didn't work. So I tried filling the maze with shaving cream to see if it could force its way through, but the pressure was too much for the maze. I even dyed some water blue and poured it through the maze, which was satisfying to watch, and it did eventually reach the end, which was a cool experiment in and of itself, but it definitely wouldn't beat the average human, and it also made just about every wrong turn along the way. And no matter how hard I tried to bend the definition of robot, water just doesn't qualify as a robot, because it's water. And my goal is to create a robot, or at least an object that could solve a maze faster than a human. So I kept testing objects until I finally found something that worked. It may not look like much, but it's great at solving mazes. Instead of creating a partial vacuum, I used the wind tunnel effect to my advantage. But this specific object's shape allowed the air to rush underneath it and pin it against the maze ceiling if it got going too fast, temporarily slowing it down until it could fall back into the current. It also had a free spinning piece inside that could shift its weight if it got stuck in a corner, helping it get back into the airflow, which allowed the little robot to solve the maze in 11 seconds. Now it was time to see if my robot was faster than people. To get an unbiased average, I asked 100 random people to solve the exact same maze as fast as they could. And the average human was, wait for it, 12 seconds. So for the first maze, my robot won the point. With 2 more crazy mazes to go, it was still anyone's game between my robot and the humans. But for the next maze, I was feeling pretty confident. I had designed several 3D mazes as a kid, but I had never built one. So I was excited to finally create one. First I drew it on paper, then I built it in CAD, and 3D printed it. And for the cover, I cut squares from these paint container things, and then glued them to the maze. And for some reason, I thought this one would be easy, but of course, things never go exactly as planned. I tried a few objects, but the robot kept stopping at a corner because I only glued the edges of the cover to the maze instead of every single wall, which allowed the air to leak through the wrong path. When I removed the cover and tried to fix it by sanding, I accidentally melted the whole thing and there was no recovering after that. I could have reprinted it, but I was already way over budget. Which reminds me, these videos aren't cheap. And I'm not gonna ask you for your money, but if you wanna support me in these videos, then you should take a second to subscribe because it's free and it really helps me out. Anyway, for this maze, I had to take the loss and give the points to the humans. I obviously couldn't have 100 people solve this maze, but my wife solved it beforehand, and my robot never even made it all the way through, so it was a tough loss. But with the final maze as a tiebreaker, it wasn't over yet. This maze was a bit different because it's based off of those follow the line puzzles that you see in little kids books, where you start at one end of the line and try to get to the other end of the same line. The difference is there aren't any direct wrong turns. Basically, I just got 3 clear tubes and twisted them to make one of these maze puzzles. And with this maze, I had much more success. I started out by using this little robot I made out of 2 fidget spinners, and it worked great, but I wanted to make sure that I won this last round. So I kept testing some more objects, and after a few more tests, I found the winner. It turns out about 6 inches of fluffy yarn goes the very fastest. It's so fast that it's hard to even see the path it takes. But if you watch in slow motion, you can see it traveling through the maze in less than 1 second. And what's cool about this robot is that it's not limited to 2 dimensions. It can climb up and down without a problem. But now it was time to see if it was faster than humans, by having some more people solve an exact copy of this maze. And it didn't take long to see that my robot was much faster than any human. In fact, this robot can solve this maze faster than the world's fastest maze solving robot. Granted, it's not really a robot, and this isn't really a standard maze, but regardless, I feel like I fulfilled my goal of not only reviving, but leveling up the maze solving skills I had as a kid. I hope you enjoyed this video. I try really hard to make them as entertaining as I can while also keeping them completely family friendly to fulfill my quest of filling the world with wholesome and entertaining content. If you would like to support me and help me fill the world with this kind of content, then there are a few things that you can do. First of all, subscribing really does help because it usually means that I get more views on my videos, which means more people watch ads, which means I earn a little bit more money, which I put right back into my videos to make even better videos for you. The other thing you can do to help is share this video with someone who you think would enjoy watching it. And that's pretty much it. So thank you so much for watching.